Okay, well, at least you haven't all run away, so there's a chance maybe you're planning to stay then. All right, so that's great. Okay, just a reminder that attendance is now officially started, like as of yesterday. Just a reminder, it was on last week's slides, and of course also in the recording, but just in case you didn't see last week's slides, just a reminder, the way how attendance works in this room is, yes, the attendance is generally taken by the card taps in the back. I do expect that you will tap your card and you'll check against your phone to make sure that the item has been recorded. If for some reason there's an issue with your card or you've forgotten your card, then there is a sheet of paper that will be kept up here at the front of the room. You can sign that at the end of the lecture to say that you were here. Once you leave this room and I leave this room, I will not take any updates by email with complaints or claims of, yeah, I was there and I participated and I forgot to sign, I forgot to scan. No. So make sure, check. If it doesn't work, do this. My recommendation is always like this. Once you reach about 10% absent, my recommendation is just sign the piece of paper every day. That way it's absolutely no question, and it isn't suddenly like, oh, the card reader didn't work and I'm over 15%. Just when you reach 10, just sign all the time. There's no cost. If you sign and you scan, it's okay by me. I mean, it wastes a little bit of my time, but that's all. All right, so here we go. We continue on with the same types of things we were doing last class. Again, I apologize. Maybe it's a little bit dull because, well, it is kind of a review of everything. I always do this at the beginning of the semester, not to try and bore people to death, but it's just to kind of make sure that everybody does know a couple of really important things. Like maybe you picked up a couple of things last class, maybe it'll be one or two things here this time. Eventually, the idea is that this whole review business just goes, but at the moment it's here, and I always know the first week of full classes, sometimes I'm missing people, so I try not to put too many new and crazy and really important things in the first week. Next week we should actually begin with real material. Okay. If anybody else would like to teach the class, it's completely fine. I'm quite happy to go do other things. So no, remember the same rule. If you don't want to be here, we actually don't want you here either. If you have things to discuss, it's perfectly fine. Outside is okay. All right, so here we go. What we're covering today is a little bit of stuff about types. Really, I think the names need to be updated a little bit more because there's some things, it's not really types so much, it's really about types and operators. So, sorry, a little weird. So what we're going to cover today is we're going to cover some string basics. And again, I know that strings have already been covered in 1101, but there's a couple of things that sometimes people don't quite get from them, so I don't mind repeating them. We'll talk about type conversion. We kind of did this already. We'll talk about mixed data types, floating point errors. Okay, we'll read this section actually, but don't cover them here. Dividing integers and some more strings. These are the sections from the book that we'll actually be up to. All right, so here we go. I think the first couple of things will probably, well, okay, I'll just leave this one, then I think we'll probably flip over to the interpreter because it's a lot more interesting. Yeah, okay, so we have a bunch of primitive types. Okay, well, we actually started on some primitive types yesterday, so hey, let's do it. Okay, so let's do it. Let's make one variable, and oh, as much as I hate using the value x, okay, maybe I won't, I'll use the variable called value. Usually you shouldn't use a variable called value either because it's just too generic. Use it to store whatever you're storing. So if you're storing test scores, call it test score. If you're storing number of laptops, call it laptops. Anyway, for today's exercise, a lot of the things I just use very generic names. All right, and we talked about this yesterday. Hey, if I set values equal to 56 and I ask a very important question, not printing the value, not printing the actual contents of value, but printing the type of value. And that was the new function that I introduced yesterday. What type is value? Yeah, it's an integer. Excellent. Now, something very, very important. Okay, well, this is a trick question. How about this one right here? It's a string, yeah, and you can tell because it's got the quotation marks. Something that is incredibly, incredibly strange in the world of Python, especially if you're coming from an older, I hate to call it older languages, but strongly typed languages. You see, if this was a program written in Java, this would have a problem. because on line number 1, we said that value is a string, and then on line number 2, some of them are saying it's an integer. You can't do this in what's called strongly typed languages. Python allows it, by the way, and if I run the program, what types does it say? Int, because it will always take the most recent thing. Okay, so yes, types of values or types of variables can change over time. Okay, just to keep that in mind, that's not an error, it can change over time. All right, so there we go. Nothing very difficult about this. And okay, so I think everybody knows the answer to this one. Yeah, it's a float. Okay, good. Did anybody explain why it's called a float? Because why did they call it float? Why didn't they call it something else? Why didn't they call it decimal? Yeah, unfortunately, they never cover that, do they? Okay, I'm going to give you just a quick little intro. Okay, if nothing else, okay, don't worry, I'm not going to ask questions about this on any test, but because they don't actually cover this in the 1101, let me take like half a minute, I'll explain why they called it a float. This isn't exactly how it works, but it's going to be very, very close. Okay, just so I can type some stuff. Okay, so don't worry, untested material, just for general purpose knowledge. All right, so this is not a trick question. Okay, okay, that's a number. All right, that's 1,435. Let's make it a little bit more interesting. 0.9. Okay, what does it mean? I don't know, maybe it's the price of something. I would like to make a little change to it. Okay, and this should remind you of a math class. I don't know if they cover this in any of our courses here. All right, but I'm going to ask you a very simple question. Okay, there's one value. Okay, I'm going to write the same number again, just so I have both of them up. Okay, and I'm going to ask you, is that the same number? No, of course not. I mean, 143 versus 1,435.9 versus 143.59. But you'll notice it's the same digits. Okay, it is the same digits. Now, I can do one thing that will make this actually be the same. Okay, let's pretend that that means multiply by. Okay, so I know in Python you use star. All right, that is a 10. And even though this is not Python, that's why I'm not in Python, I'm in a text editor. Okay, so this is 143.59 times 10 to the power of 1. Is that the same value as the first line? Yeah, and what did I just do with my decimal point? I just floated it somewhere. That's actually why. So when you're really storing numbers and storing decimal numbers, really what you're typically doing, or what the computer is typically doing, is it stores numbers like this. Those two are exactly the same number as well, but what they've done is they floated the decimal point up to the beginning. And this is actually the reason why they use the word float, because they take the decimal point, they move it right up to the beginning, and they simply multiply by 10 to the power of something. That's not exactly what they do, but it's really, really close. What they do inside the computer is it's binary numbers. But that's the reason why it's called float. Okay, it isn't just like, hey, let's come up with a name of calling something. I mean, why not decimal? All right, that's why. Don't worry, no questions will ever be asked about this on any assessments. This is just in case you're wondering why. I think it's important sometimes to know. Okay, then we'll have to talk about conversions in a few seconds. So here we go. Boolean, okay. When I run this, it comes back with with something called a bool. So yeah, that is something very, very different. Oh, and what about if I put quotation marks around it? Yeah, that suddenly becomes a string. Very, very different. Okay, that's important. Sometimes I get students returning from a function true inside quotation marks, but that, of course, is not the same thing as true when it's not inside the quotation marks. All right, and I guess since we're here, how about this one? Yeah, the word true, all written in lowercase, becomes a variable, and if I try to run this, good, I think I heard a name error, yeah, because true doesn't exist. Okay, now, unfortunately, here's something that I could ask, is I could do something like this. I mean, that's allowed, right? because what I've done is I've said that true is now equal to false. The variable true is now set equal to the value false. So true is actually a Boolean values. And yeah, I can do some really, really bizarre things now. And yeah, these are the types of crazy questions sometimes that I ask. So watch out. Okay. All right. So there you go. Nothing weird about this one. Okay. Let's see. So we now need to cover a bunch of operators. Okay. Again, we started to talk about these yesterday. These are not meant, again, to be very difficult problems, but it's just to make sure. Okay. So here we go. We need to take a couple of values. So I'm going to use the values x and y. I'm sorry about that. I'm going to have x is equal. Do I want to do this? You know, I'm just going to hard code the values directly. All right, 23 plus 1, and if I print the value and we print the type of value, those are the two things that I want, is both the type and the value itself. All right, so the first thing is, what type is value? Integer, okay, and what's the value? 24. At least I left the calculations simple. All right, excellent. So obviously everybody understands what that does. Okay, that's really nice. I suppose I should make this a little bit more interesting. I'll make it 4. 4 should be good. All right. And of course that means, oh, sorry, we'll start with this one. Yeah, subtraction. Okay, so what's the value? 19. Yeah, nothing funny about this. And of course this one right here. Yeah, multiplication. That's no issue. So I won't ask you if you know what 23 times 4 is in your head. Obviously, we know the number is 92. Okay, that's important. All right, and then, of course, we bump into this one right here. Yeah, that's division. Okay, good. So my question then, sorry, give me 1 second. Sometimes I have MySQL Workbench busy, and it bothers me. So let me close that up so it stops bothering me. All right, and I'm going to have to ask a question. What on earth is 23 divided by 4? All right, now, I'm not expecting you to be able to do this by hand, so hey, let's pull out a calculator. And yeah, most of the time, if I ask you to do calculations like this, yeah, a calculator will be available, so we better look at it. So here we go, 23 divided by 4. So you come over to your trusty calculator, type 23 divided by 4, and it says 5.75. Okay, so if I run the program, I now have to ask a couple of questions. Okay, and this is where now things start to become interesting. Because that value says 5.75, and what type is that if it was over in Python? It's a float, but I have 2 integers. So if you take an integer and divide it by an integer, do you actually get a float, or do you get an integer? And if you get an integer, what value do you get? Around, okay, so now we have to go figure out what's going on here, okay? So we'll do this by experiment, and then we will summarize exactly what happened. All right, so here we go. First one up, I will clear this. So our very first one is we want to know what type it is. We have no idea, and we want to know the value, but if we knew the type, maybe we can predict the value. So let's do it this way. In other words, it's not going to run the value. Let's just look at the type first. Okay. It comes back as a float. Now, you know, that's actually nice because that matches what the calculator did. Okay, that's helpful. All right, and what do you expect the value is going to be then? 575. Okay, excellent. So let's uncomment and actually see what's in here. And yeah, it's exactly what you expected. Okay, that's really nice. Okay, that's the first thing. Let's see what now we can do. Now, some people said, hey, it's going to be an integer because it's an integer divided by an integer. People who answered that, I have a prediction about why they may have answered that. If you work in a language like Java or C++ or C#, that's exactly what it does. You take an integer and divide it by an integer, you get exactly an integer back. Okay, so don't make fun of the person who said that, because that's a legit way how it works in other languages. Now, I know that often I've said already, we don't tend to use a lot of decimal point numbers, but we do tend to do a lot of division. Okay, so division is something that actually happens. So yes, if it looks like I spend a bunch of time reminding people about how division works, it's kind of really, really important. All right, so even if you were to take 2 integers, or if you take a float divided by an int, that will also give you another float. Of course, it'll give you a completely different value. Okay, so there you go. So yes, anything a single slash will give you a float. Okay. There's another one, however, so I'm going to put this one back to this one for a second. Okay, good. So I hear somebody yelling, hey, there's a double slash. Okay, that's pretty important. Okay, in a double slash, it does something a little bit different. Okay, let's once again get rid of this for a second. Okay, get rid of this. All right, and we already know that 23 divided by 4, we saw this right here, it's 5.75. What I'm going to do is I'm going to run it just to see the type. And you'll notice that the type is now int. Okay, so if I print value, is it going to be 5.75? Definitely not. All right, so I heard earlier, now I've heard two numbers. Somebody just yelled 5, and a little while ago somebody suggested 6. Okay, yeah. All right, so now we have a dilemma. Does it round to the 6 because it's closer to the 5.75? Or is it the person who said 5 and it seems to be throwing a bunch of stuff away? All right, well, here, we'll uncomment this, okay, and we'll let it run. And what it does something called truncation. Okay, it does something called truncation. So whatever happened to be at the very end, yeah, it simply goes away. And what I'm going to do is let me take a stab at a kind of a more interesting problem. Let me do it straight division first. 23 divided by 24. Okay, now I'm not expecting you're going to know the answer to this off the top of your head. Okay, but I'm going to ask you a very simple question. Is the number, when I printed, it's only one slash right now, is that number above 1 or below 1? It's below 1, right, because it's 23 divided by 24. And guess what? It's going to be a number that's really close to 1. It's going to be like 0.9 something. Okay, and that's exactly what it is, 0.95. Now, if I turn this into a double slash and I say, okay, I want to use this operator, I'll give it a name in a second, you have to avoid the temptation that it might turn into 1 because it gets rid of everything after the decimal point. And it doesn't matter how close you were, even 0.9999999 would still end up becoming the number 0. Okay? All right, the official name for this operator, if you had come from a background where you're using Java and C++ and so on, these languages, when the first time I saw this, I started calling it the integer division, because that's what they called it over there. This is not integer division. This is actually something called floor division. Okay, here's how it works. It does the division just as normal, and then it brings you to what's called the floor. Okay, what's the floor? Well, that's the thing I'm standing on. Okay, so you can imagine, okay, so here, if you're watching the recording, you won't be able to see this, but imagine that the floor is 0 and the ceiling is 1, and right here, this is like 0.5. Okay, a little bit higher, this might be 0.6, 0.7. The floor is down there. So if I have a number like 0.7 and I say, please apply the floor, where does it go to? It goes to 0, goes to the floor. All right, and if this happens to be the number 5, this right here would be 5.5. So if you apply a floor, it goes to 5. Oh, that's pretty easy, just that direction. Okay, things can get a little bit weird. Okay, and there's one case here where things do get I'm going to describe it as very, very strange. All right, let's put it back to this one for a second. Okay, we already know the answer to this. It's a float. It's 5.75. Okay, a little bit of math. If you take a negative number and divide it by a positive number, you get a negative number, and what value is it going to be? Negative 5.5. All right, so we run it. Yeah, that does exactly what we expect. Okay, so here we go, and if I do floor division, yeah, it seems like negative 5, and that works perfectly fine until you run it and it says negative 6. And you go, what? Okay, remember what it's floor division. Because if I'm talking about 5.75, I'm talking like somewhere around here, and that number right there must be minus 6, and that number right there is minus 5. Okay, that's why. So it always goes down to the nearest integer. Even if it's negative, it goes down to the nearest integer. Please keep that in mind. I always throw in these questions, by the way, and people always get it wrong on like midterms and so on. It's a nice quick little check, okay, to remember the floor division. Just be wary of it. Okay, does it surface often in programming? I'll be honest, it doesn't show up that often. It's kind of more of a theoretical thing, but it is actually kind of important. And if you do have negative values, you have to be aware that they're going to become even more negative. Okay, so it's something that's a bit strange. Okay, let me see what else I've got in here. All right, we got an extra one. Oh, sorry, now we got more stuff. Okay, let's get rid of negatives. Okay, because honestly, we don't use them that often. All right, there's another operator, very, very important. This is really, really critical in the world of programming. You would have seen it in infs 1101, and it will continue over and over again. Sorry, there we go, we'll finish it. All right, we have mod. Okay, good. Don't call it a percentage. I mean, you can call it a percentage sign, but really you shouldn't say that ever. Say it to yourself. It's actually the modular operator. Okay, so what on earth is a modular operator? The easiest thing for me to do is to show you this one right here. The modulo or remainder operator. Okay, so here you go. Here's some long division. Okay, so if we took the number 4,235 divided by 17, you do it the old-fashioned way without a calculator. What you end up with is the value at the top. This is called a quotient. That will be exactly the result of the floor division, unless you have like some negative values and the whole thing is messed up. Okay, this will be exactly the result of the floor division, and this thing down here, this is the remainder that you get. Okay, all right, so I mean, we'll actually try that number in a second. Okay, we'll put it away for right now. All right, so the question then becomes is, okay, if I divide 23 by 4, what's the remainder? 3, okay, because 4 will go into 20 exactly 5 times, and of course that would give you 20, and there would be a remainder of 3 afterwards. Okay, so there you go. All right, that's fine. Everybody understands this. It's how do you use it a little bit later, and yeah, this can be a bit more difficult. Unfortunately, in this particular Python environment, you can even take floats and use the modulo operator. I don't like to show it because it doesn't really mean anything, but just to let you know. It actually shows up all the time. One of the things that we use it for very frequently is to find out whether or not numbers are evenly divisible by other numbers. Okay, we use this all the time. Like, for example, is 23 evenly divisible by 4? No, because it's got a remainder of 3. What about this one right here, 20? Yeah, 20 is evenly divisible by 4. What's the remainder? 0. So if you ever take a number, you want to know if it's evenly divisible by something, you do this. And you say, what's the point of doing this? Okay, let me see. I don't know whether or not I can grab this and move it over. Okay, I don't know if this will show up in the recording. Okay, so if you're missing it, that's too bad for you. All right, take a look at this. The very last set of numbers, you see it going right now, it says 48, 49. What's going to happen when it hits 59? It's going to go back down to 0, and there's going to be one extra number. That's what we use modulo for. So what we do is we say, oh, look, it's now divisible by 60, so let's put it back to 0 and let everything continue. There's some really, really clever things you can do with modulo, and I will show you this. Like, for example, here we go. If seconds, okay, so at least if you're watching the video, you'll get to see it. All right, 45, okay, here we go. Print seconds. That's not a trick question. Then I'm going to say seconds. Okay, you guys remember that operator, right? Yeah, so this is exactly the same thing as saying seconds plus 1. Okay, I will use this all the time. You're not required to use it, but I will use it all the time. And I'm going to print seconds. Okay, not a trick question. It's 45, then 46. And if I copied and pasted it again, if I had a loop, that I could make this better, but that's fine. I won't bother with it yet. Okay, let me put it up to 56. All right, when I run the program, this is not a trick question. What's going to show up? Yeah, 56 and then 57. Okay, here's what I'm going to do. I'm going to copy and paste because, well, everybody copies and pastes things, right? All right, before we run it, what are we going to see? 56, and we're going to see a 57 right here, and this one we're going to see 58, then we're going to see 59, and we're going to see 60. Ooh, we shouldn't see 60 if we're trying to replace that clock. We're going to see 61. Okay, fine. Yeah, that's exactly what it is. Now, if you're thinking back to INFS 1101, you'd probably be looking at this saying, okay, well, if it's equal to 60, make it equal to 0. Okay, no, I'm going to show you something completely different. All right, so I'm going to go back to this way. I should have done this in the first place. Seconds plus 1. Okay, just so I can demonstrate that, yes, I'm not doing anything. I'm doing weird stuff. Here we go. This one, okay, and this one. That's exactly the same program, okay? But I'd like to make a little change, just so I can prove there's a reason to have the remainder operator. So I'm taking seconds plus 1, followed by the remainder of 60. Oh, and I'm going to replace this here, 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 and here. Okay, now you look at that and go, what is he doing? And now I got to calculate the remainder each time. Okay, well, here's the deal. If you have the number 56, that gets printed. Excellent. All right, on this line right here, if you take 56 plus 1, what do you get? 57. All right, if you take 57 and you divide it by 60, how many times does it go in? What's the quotient? 0. And what's the remainder? 57. It's exactly the same number because it's less than. All right, and then we're going to repeat it here, then we're going to repeat it here. But when we get to this one right here, it's going to be 60 because 59 plus 1 is 60. If you take 60 and you divide it by 60, what's the remainder? 0. Excellent. So it's gone back to 0. And then it becomes, oh, well, now it's 0 plus 1. Yeah, it's back to 1. So automatically, I got my wraparound without having to use an if statement. We use this all the time in programming to have things wrap back around again so we can keep on going. Random number generators work exactly this way. The thing that makes all of the internet secure, this thing that's up here, you can't quite see it, HTTPS, it's all based on modular arithmetic. So if somebody says it's not important, yeah, it's actually really important. It has everything to do with anything to do with security. Okay, it's really critical. We don't see this type of stuff in this course, which is too bad, but obviously we have to learn something. But I use modular arithmetic all the time for creating loops of numbers without having to use if statements. It's really handy for it. Okay, so that's why when I'm talking about back here, in fact, my little comment said it's really useful for checking a number of easily divisible. That's about the extent of what we used. It's good for wrapping around something called circular buffer in lists. Okay, well, we might see this in a list. We might, and we use it in something called hash functions, not in this course, and it's used in a lot of cryptographic algorithms. So it is actually really kind of important, and it's also just really cool. All right, so let me see what else I've got here, because I think I skipped one. Okay, here we go. Value is equal to, okay, 2. Okay, this is not meant to be a trick question. What's the value? 8. Okay, good. Yeah, it's 2 times 4. Oh, okay, well, I'll leave it a little bit bigger. Okay, this one? 60. Yeah, this is an abbreviation for 2 to the power of 4. So it's 2 times 2 times 2 times 2. And yeah, that's going to be 16. If you need an exponential, if you need something to raise the power of something, yeah, it's completely fine. Okay? All right, so that's out of the way. Let's see, have I done everything? I think I've done all of the stuff. That's good. I just want to see my examples to make sure I'm not missing anything. Okay, get this one. Okay, good. So everybody understands. Oh, sorry, the final thing, just to make sure everybody understands. If you ever change the size of the font, by the way, in this editor, you have to press enter somewhere, then everything works. So no need to complain about it. All right, here we go. 1 plus 3 times 2. Now, I have to put this up because I keep seeing this in social media posts and everybody argues about what the value is. All right, so there's always 2 things that show up. A bunch of people will be yelling 7, a bunch of other people will be yelling the number 8. Okay, so which is it? 7. Okay, good. Yes, that's exactly it. Remember, order of operations. Yes, Python does preserve the order of operations, and it will do the multiplication first. okay, because obviously that has a higher precedence. In order to remind yourself that it's doing this, and you'll see me do this, here's the trick that I use, okay? And you'll find a lot of Python programmers will do the same thing. Remove the space between the multiplications. Is it required? No. Is it helpful? Yeah, it's just a reminder that the multiplication happens first. Okay. You'll see a lot of people do this. Those standards that I talk about called PEP 8, they actually recommend this as well. If you don't like the order and you really want it to do the 1 plus 3 first, then it's fine. All you do is you do this. Okay, so parentheses, again, it will change the order of things. And yes, I also do exactly the same thing. I avoid putting spaces between divisions and multiplications, and even exponentiation. Spaces between plus and minus. It's not a requirement, but it's a pretty decent practice. Okay, all right, so let's see what else we've got. Okay, so we got some new things. Okay, here we go. Here's an operator. Okay, now I'll just use exactly the same one that I've got here. Okay, only because we've got this. All right, so what type is operator? Not a trick question. It's string. Okay. Oh, single quotes, double quotes, entirely up to you. Here's what we're going to do is we're going to say print operator. Nothing very funny about this. Modulo operator. Okay, perfect. Now, the reason why I'm doing this is because I would like to have another variable, and I'm going to say is equal to operator. I'm going to print value, and I'm going to ask once again a question: what gets displayed? So modulo operator. Okay, no difference. All right. Now, the reason why I wanted to do this is because I have to introduce something. I know in infs 1101 you would have seen the square brackets. The official name for those square brackets is called an index operator. Okay, this becomes really important because if you make mistakes, Python will probably talk about index operators and you have to know what they mean. Okay, like for example, if I leave this out, okay, it just comes back and it says invalid syntax. Okay, we'll be able to generate a different error in a few minutes. All right, normally what you put inside this is one of a couple of different things. Like for example, what you could do is you could say, we'll stick the number 2 in here. All right, and what you're doing is when you have a string and you're using the index operator, you're requesting to Python to please go into the string and pull out exactly one character at position number 2. Okay, so it's a single letter. D, okay, yeah, and if you run it, yeah, that's perfect. That's exactly what it is. So you guys remember, of course, that the very first letter is at what position? Yeah, of course, okay, that's what it is. And so that's the very first M. And you might say, how come they started from 0 instead of starting from 1? Okay. All right. So let me see. Did I include a picture of this? It probably includes some other things. I don't know. Okay, here we go. Give me a second, and I'll just make an extra slide so I don't put too many things. Ooh, that's not helpful. Okay, and again, if the rumbling is making it to my side, people back there are probably also kind of irritated. So please. Makes the class longer, I guess. Okay, so here's actually the string. That's the reason why I picked modulo operator, because I knew I had this picture already in the slides. And yeah, so the very first character is at position number 0. The very last character is at position number 14. Okay, so that's pretty simple. All right, now why did they start from 0 instead of from 1? Okay, historical purposes, but it also has an awful lot to do with the way how memory is stored. You see, when you store a string, it gets a certain place in memory, okay, and that's going to be the beginning of the string. And if you're interested in the first character of the string, you're probably expecting to be at position 0 within that. It's the very first byte. And the first byte is 0 bytes away from the beginning. That's why they use the number 0. I suppose it kind of goes along with the approach here. Hey, we do this. When you go into a building, what floor are you on? Ground, yeah, well, usually, okay. And if you go up one floor, what floor do you end up on? Quite often 1. If you go to North America and you go into a building, you end up on the first floor. And then if you go up one floor, you end up on the second floor. They have a different numbering system, which is better. Well, whatever it is, but you have to keep it in mind. And if your initial reaction is like, well, I'd rather it be 1, okay, well, different languages do allow you to start from 1, but Python doesn't. Okay, it has to do with the way how memory is managed. Okay, so now if we were to go and we were to ask, where's my thing go? Here we go. So if I asked for 14 because you saw the picture a second ago and I run it, what do we see? R. Okay, excellent. All right, and if I ask for position number 15, what do I get? Okay, well, I'm hearing two things. I'm hearing error, and error is not spelled with an M, but I'm also hearing M. But in any case, let's go ahead and run it, and the answer is yes, it is an error. This is an index error. Okay, you've asked for an index that simply does not exist. Okay, so that's it, just doesn't exist. All right, so, and if you ask for 15, 16, 17, yeah, it also doesn't exist. All right, but the curious thing is, and you guys would have already bumped into this, what about position -1? Yeah, so it does something really weird where it wraps around to the end, okay? And that's exactly what it is. That's the very last character. Please watch out for this if you continue on with programming in other languages. This is not something that happens anywhere else. This is a Python very specific thing. It's very nice because it gives you access to the very last item, okay? But other languages simply don't provide it. And if I ask for position -2, it'll be the O, which is the second to the end. And if I ask for position -20, that becomes an error because what you're doing is you're saying come all the way back, and yeah, that doesn't exist. So once again, an index out of range type error. Okay? All right, so that's pretty straightforward. All right, so let me see what I've got else in here. Okay, that's actually all of the examples that I had. Okay, excellent. All right, another thing. Now, this is not something that I really find to be incredibly useful for a lot of things, but I can easily make up good uses for it. Okay, in fact, we might as well use it to solve a small problem today. Hey, this will be kind of cool. It's an exercise sometimes I get students to do in classrooms. But in any case, here's what I want to do is I would like to introduce another operator. Oh, but it's the same index operator. Here we go. But they use it in a slightly weird way. Okay, if I put 2, D. If I put a colon, and I put, let me see which one. And I say 5, okay, what I'm doing is this thing right here, this is called a slice. Now, we don't use it a whole lot with strings. I mean, sometimes it's useful. Really, I use slicing all the time with lists, and we will see it. But the good news is it works exactly the same way. And what this is doing is this is saying, please go to the string and pull out some characters. Which characters? All right, I've given 2 values. Okay, this is kind of like the base case. Okay, so I start with this one because it's easy to understand. This says begin at position number 2. And it says keep going until, well, it says 5. Yeah, okay, let's run it for a second. Okay, and it comes back and it says it's dull. Okay, yeah, Python can be dull, that's fine. Maybe the modular operator can be dull. But you'll notice what we've got is it did include the character at 2, that's 1. It included the character at 3. It included the character at 4, but it didn't include the one at 5. Yeah, so what it does is it stops just one before. Okay, that's the way it's done. And if you say, I don't like it, well, complain to the people who build Python. And again, it has to do with the fact that things start from 0. It makes some of our calculations a whole lot easier. Okay, so basically you go until a certain point. Now, I've got to do one extra thing. Sorry, I forgot to cover this earlier. So let me go back to here, type of value, and I have to ask the question, okay, back, I'm asking for only one of the letters. What type is value? Oh, I heard it. Somebody said the nasty word called char, which does not exist in the world of Python. Everything is a string. Even a single letter is still considered a string. It's a string with a single letter. It's kind of weird. If I go back and I give you the slice once again, okay, that's also a string. All right, now we better go a little bit further. Okay, so if I went to, let's see, Okay, what will I see? Double O. Yeah, there's a space at the end, but it still looks like Dello. But there really is a space. How can you tell there's a space? The only way I can tell is if I highlight it, you can see that there's one extra thing. Unfortunately, spaces are invisible, but they are there. Now, if I ask you a question, how many characters are inside the string called value? Yeah, there are actually 5. There's a D, U, L, O, and the space, and yes, it does count. Okay, so reminding, these are things that get people into trouble. All right, so there we go. So remember, it goes until 1 before the number. So if I put this one in, you'll start to see the beginning of the next word. Okay, so it really is there. Okay, again, I'm not being nasty. It's just I know that I will get emails with people saying, hey, come on, it's way too noisy back here. My recommendation, if you do find it noisy towards the back, there are seats at the front, and you don't have to, but it may avoid some of the conversation that happens in the back. Unfortunately, it doesn't, because the conversations just continue. Yeah, I'm talking about you. Yeah, thanks. Okay. All right, so here we go. So everything is a string, okay, and this can be used to pull out small sections of strings. Okay, here, let's turn it into a real problem. Okay, so here we go. Course code. Course code input, enter the course. Okay, so I'm talking about infs1201. All right, course codes always consists of how many characters? 8. Okay, excellent. The very first set of 4 characters, by the way, is always what falls under something called the department. Okay? INFS, INFT. I'm not sure the other one. ACCT, I know that's an accounting one. Let's see, COM 1010. Okay, COM is it. That's the department. It's always the first 4 characters. Oh, okay. So if I only want the first 4 characters, what I could do is I could say the course code, and I could say, okay, give me everything from 0 until 4. All right, and then there's the course code. Okay, so let's call it the, what do they call it? It's, I'll just call it number. Okay, here we go. Course code. What I could do is I could start at 4, and I could go to the end. Okay, so take a look at this. So print department. Oh, here, I'll use an F string just so it's more interesting. So department is equal to department, and print F num is equal to number. All right, so now what I've got is a really cool little program. So 2201, there you go. You break it up. So there's the department, there's the number. Yeah, this is what we use string slicing for. Now, there's a couple of interesting things about this. Because we quite often do the slicing where we start from the beginning and go to a point, there's a shortcut. Okay, it's important that you know the shortcut because everybody likes shortcuts. Sorry, it's not a tremendously exciting shortcut, but there you go. That's the shortcut. Instead of putting a 0 at the beginning, you can leave it out and you can save yourself typing 1 character. That's pretty impressive, isn't it? So you have to type 1 character less. Here, let me close it and I will show you that yes, it still works. So RSS T4444. There you go. So yeah, it still works. It's a shortcut. You don't have to put the 0. That's one. The second one is quite often you're looking for the end of the string. And if you leave it out, it assumes it's the end of the string. And that against, hey, we saved 2 characters of typing. All right, so here we go. Tom 10. Okay, yeah, we saved ourselves a couple of characters. All right, so leaving out the first one means you assume it starts from the beginning. Leaving out the end, second one says go to the end. Very useful. All right, so that's handy. There's an extra one as well, which is, I'm just going to describe it as kind of weird, but I have to include it. Okay, here we go. Course code 1. No, let's go from 0 to 8. In other words, the entire string from the beginning to the end. There's another number that can go in. The final number is something called a step, and this is saying how many characters to skip between each. So what this is doing, this is go to the first character. The very first character is going to be the letter C. Oh, I better print it before I run it, otherwise it'd be really boring. So the very first letter is going to be the letter C, but then And instead of looking at the O, I'm going to skip one, because that's why I've got a step size of 2. So I'm going to see an M, then I'm going to see a 1, then I'm going to see another 1. Okay, oh, sorry, I'll just type in now jan14 again so I get the same output, but there you go. So what I'm doing is I'm picking up every other. Okay, useful? Absolutely not. I have never used a step size ever in a string. Why am I covering it? Because it's here, it only takes a couple of seconds. We do use it in lists, but in strings, almost never. All right, but I do have one kind of really weird thing. Let's make sure I'm covering this one. Okay, good, it is here. Oh, and by the way, that's exactly the same. Remember, you can leave out the first one, it's automatically assumed to be 0. You can leave out the second one, it's automatically assumed to be the end. It works exactly the same way, so there's another new course number for you. It still does the same thing. All right, there's one kind of weird little thing that is here. I'm just going to call it a novelty item because I don't see any other point for it. I'm going to put an 8, I'm going to put a 0, and I'm going to put a -1. So now the step size is backwards. It says go start from the end, step -1 each time, and go back to the beginning. And yeah, if I said jan14, it'll come out exactly the opposite. Oh, except it looks like I didn't go quite far enough. Okay, yeah, I would actually have to make it -1 because remember, it leaves the very last one out. That's why I don't really like this one very much, but here you go. -1. Okay, let's try it one more time. jan10. Ooh, okay. So it didn't do anything for me. Yeah, trying to pick up the very last character is kind of a little bit weird. All right, so yes, you can actually flip things around. Useful? No. No. It's kind of more of like a trivia thing that we do sometimes, like in a first year course. I've honestly never taken a string and said, hey, let's print it backwards. Except in infs 1101 and 1201. However, sometimes these negative step sizes can be useful if you need to process a list backwards, but there's usually better ways of doing it. Okay, but okay, so as I say, just a piece of trivia, because it usually shows up in slides and so on. Okay, let's see what else we've got here. We're almost done. Okay, here's the next one. Okay. Department, infs, number. Okay, we actually kind of stumbled upon this yesterday, but we'll just remind you. What gets displayed? jan1201. Yeah, the code now becomes a concatenation. I suppose keeping in store what I did before. Yeah, I'll leave the space in here. Yeah, nothing weird about this. It's concatenation. Okay, so if I ever talk about string concatenation, that's what we're talking about. All right, let's see what else we've got here that would be useful to know. Okay, table of contents. Okay, here we go. I suppose I should have just printed this, copied it directly, but that's fine. Here we go, operators, we've done that, and we did space 4 and functions. All right, first of all, I know everybody's gonna look at that and go, that's not very nice, is it? It's too big. Okay, that's fine. Print the table of contents. Bang, there you go. Okay, so first of all, yeah, I don't like it because the code is too big. No problem, we can keep it on a single line if I go back to there. And of course, you can't see it, but I can. It's all in one line. Is it over 80 characters? I bet not. Okay, but in any case, here's what I want to do. I don't want, when I print it, I don't want to print it this way. I want to print the output one on each line. How do I make this work? Okay, I got a couple of things that I can do. The first thing I can do, you would have learned this in 1201, is you learned about the character \n. That, by the way, is not 2 characters, it's 1 character. But it's 1, 2. No. When you see a backslash, Python says, okay, what's the next character? That's a new line character. When you do this, of course, it causes things to appear in the next line. Oh, hey, that's nice. All right, so all that I would have to do, if I can put some backslashes n here, and I can put a \n here. There we go, you run it. Now we've got, okay, I got some spacing. Yeah, that's not that nice. Okay, I put a space here, and maybe on 2, I can put a space here. Excellent. Hey, now I got a nice table of contents that I can print. Okay. I don't like it in the code, though. It's hard to read. Okay, so what can we do? All right, first of all, it's a little too long, so can I put it on the next line? Okay, I suppose what we do is we find out whether or not we put it on the next line. Does it work? And no, it doesn't like it. Okay, so yeah, unfortunately, that very first thing has to appear in the first line. But can I do something so I have this on the next line? And the answer is, yeah, what I can do is I can stop the string and I can put a plus and I can put this on the next line. Okay, I'm allowed to do this. Ooh, on bad type for unary plus string. Sorry, what did I forget? Oh, I've got, sorry, I put that in the wrong spot. And now I'm making things even worse than ever. Okay, here we go. We got this one. Okay, excellent. Okay, so let's give this a try. If I put it down here, plus, okay, invalid syntax. If you want to continue an expression, you might have to include an extra backtick. Okay, now I'm showing you this just in case you bump into it, so that's allowed. Okay, but now I got to remember to put backslashes everywhere. Okay, this is one approach. Just keep repeating it over and over again. I've got other techniques, and this is what I'm really trying to get towards today, right now, is I'm going to introduce you to a new quotation mark. I don't know if it's covered in infs1201, but I'm going to cover it here. 3 quotation marks. Yeah, that is the beginning of the string. Okay. Let me do a little bit of work on here. There we go. A triple quote. You can have 3 double quotes or 3 single quotes, means exactly the same thing. This is something called a multi-line string, literal. Okay, it's a multi-line string literal. The type of table of contents is still a string, but by using 3 quotation marks, what I'm doing is I'm saying, yeah, this can actually split across multiple lines. Okay, and that's allowed. This is very, very handy when you have a really long string that goes over many lines, and you don't want to keep breaking things up and putting pluses and backslashes and so on, because it makes it really difficult to write. This is very, very good for really long strings that need to be printed. These happen for real in programming. Now, usually what happens as soon as I show this, somebody who has taken the course before immediately yells out and says, it's a doc string. Okay. Yeah, doc strings are things that are used for documenting functions. We haven't covered them yet. It has nothing really to do with triple quoted strings. This is a multi-line string. Okay. Yes, we use them for those things called doc strings. When we hit functions, I'll explain what they are. Okay, but these are not doc strings. Don't call them that. They are multi-line strings. All right, so there we go. That's one of the items, okay? And next thing up, we'd better have, I see there's one extra item in here, so I better do this. So here we go, course code. Okay, and here we go, INFS 1201. There is an operator, course code. All right, the operator is called in. Okay, what this will tell me is whether or not the letter S is inside the course code. So, is there an S inside there? Yes, there is. So this will return back a true or false, and yeah, it's used for exactly dealing with whiles and ifs. That's exactly it. All right, we'll make this one very, very obvious. Is there an X in course code? No, so what are we expecting? False, very good. Is there a, let's see. Is the letter N in course code? No, it is case sensitive. Okay, so this could be useful. So you could ask the user to enter something, and you could say, oh, well, hang on, we better find out. What about, is INFS in the source code? And the answer is yes. How about INS? No, because it doesn't show up. It's used for finding to see whether or not there's a substring hidden inside something. Okay, that's what we use it for. This can be really useful. Like, for example, I use this all the time. If I have a list of codes, I'm saying, okay, I just want to see the INFS codes. And yeah, this is what I do. I put it in. You say, if INFS in the course code, then do something with it. Okay, so that can be quite useful. Let's see, anything else? Oh, here, we better ask this, because that could be a trick question. Okay, is there a 2 in the course code? No. Okay, so I thought we had, and then somebody yelled out the wrong number. Actually, that's an error because you need to have a string. Okay, so no, that's actually not there. But if I ask this question, yes, it is there. Okay, all right. So keep that in mind. How are we doing here? We're getting there. We're getting there. Okay, yeah, it will be done by 10 minutes or so. Okay, I'm not going to run the MCQs at the end because I don't trust them anymore. Sorry, we got a new thing. Okay, so here we go. I'll use this thing called this Python. I don't know if you've ever watched Scooby-Doo, but that's how Scooby-Doo would probably say Python. All right, so here we go. Print language. Okay, that's a problem. That's not spelled correctly. Maybe the user typed and we want to fix it. Okay, so how can we fix something? Now, this, of course, is not a difficult question. Language at 0. If I were to run this program, what am I going to see on line 2? Yeah, it's R. Okay, and then Python. All right, so it almost seems reasonable, and again, if you're coming from another programming language, that maybe I could do something like this, and I could fix it. Okay, that is string manipulation, and unfortunately in the world of Python, it's not permitted. Okay, so you can't change an individual character in a string. Now, usually what happens with the slides is the slides at this point will come in and say, because it's immutable. Well, actually, everything we've seen is immutable, so it's kind of a silly point. I will come back and talk about immutable things when we finally have mutable things. All right, but in any case, yes, you cannot modify a string. Once it's created, you can't change an individual character. Okay, that's pretty straightforward. Bad things happen. You get a type error, which is it a runtime error or a syntax error? Okay, if you're not sure, how can I find out if it's a runtime error? Yeah, if the program runs. So how can I know if the program runs? There you go. That's exactly it. If I see the word hello, it's a runtime error. Yeah, it's a runtime error. Okay, it's not a language issue. It's not a syntax error. It's just something that gets discovered when it says, hey, wait a minute, language is a string. You're not allowed to do that. Okay, the rest of the program runs and then suddenly it blows up. However, there is something that I can do. It's incredibly, incredibly bizarre, but why not? Okay, that's not a trick question. If I run this, what do I see when I run it? I just see the hello and P. But what I could do is I could take the full language afterwards, and now, of course, what this would give is be Python. Oh, I want to get rid of Python. But if you wanted to skip the very first thing, that's what string slicing is all about. Start at position 1, go to the end, and now I've got myself Python. So it is possible, but you have to use like string slicing to do it. Okay, it's not something that shows up very often, but sometimes you take a string apart and you want different parts out of it. Okay, let's see what else we've got in here. We're almost there. Escape sequences, I think I'll just leave because we've already covered. All right, and now I remember. Okay. Okay, relational operators. This is checking to see if one thing is greater than or less than the other. I'm going to ask you the question, is X bigger than Y? Yes, normally we use it in if statements. Yeah, false. Okay, that's good. And if I ask, is X less than Y? True, yeah. Okay, and if I ask, is less than or equal to? Yeah, it's still true. But remember, if I were to make this 200, this would now say false, because obviously 200 is not less than 200. Less than or equal to, but it's not equal. Not those two. All right, but if you wanted to check and see if two things are equal to each other, you do this, right? No. If I do this, what's going to happen? It actually gives a runtime error. Now, if you're saying that it'll actually modify it, this happens in some languages. Very, very dangerous. The good news is that X is an invalid keyword argument for print because, well, you can't assign it and do this at the same time. But you have to watch out because there will be times where I might put things in here and you go, what? But in any case, here you go. So that's not how you check to see if two things are equal. You use two equal signs. Okay, sorry, it's the language. Okay, there you go. And if you want to find out if things are not equal, okay, you covered in jan14 is the exclamation marks. And I'm going to ask, is X not equal to Y? Yeah, that's false because they are equal to each other. Okay, that's pretty simple. Obviously, we use these for all the time for other things, but let's do something a little bit more interesting. Okay, here we go. What if we start using strings? Okay, here we go. Apple and, what am I comparing in here? I must do the same examples, that way I'm not missing anything. Okay, so I'm going to ask, here we go. So really what I'm asking, is an apple equal to a banana? No, of course not. I mean, okay, here, I better clear the output first. There you go, so false. Okay, excellent. But I'm kind of more interested in this question right here. Is X less than Y? Or is that even allowed? Okay, so again, if you're coming from another language, you may look and go, no, you're not allowed to do that. In Python, yes, you are allowed to do this. What it does is it compares the two words in a mechanism called lexicographical ordering. Basically, dictionary ordering. So the question that you're asking here is, if I put apple and banana in the dictionary, would the apple come before banana? And the answer is yes, it is. So yes, this comes back as a true. All right, so in that case, what about ape? Yeah, again, lexicographical. Ape should come beforehand. Okay, so this should say false. Here, we're clear just to make sure. That's exactly it. And if I were to do something like this, apple-ly, which would come first? The shorter words come first, because if you open up a dictionary, an English dictionary, what's the very first word in the English dictionary? I know the answer. A. Just a single letter A. Right? That will be the very first word, because nothing else is going to come before it. Okay, guaranteed. So yeah, this will actually say true because apple will come before apple-ly. All right, so there you go. Sometimes you get some really bizarre things, like I've got one in here about a cat and a dog and so on. Is this going to show true or false? Yeah, true, and it has to do with the ordering. Now, there's a couple of surprises in here. Okay, you just have to watch out for them. I don't ask you to memorize these types of rules, but you have to be aware that they exist, and that is a cat with a big C, does it come before dog? And the answer happens to be yes, it does. Okay, but if I flip the order around, it isn't true. Okay, here's the deal with lexicographical ordering on computers. The uppercase letters always come before the lowercase letters. Okay? You don't have to memorize anything else, just uppercase comes first and then the lowercase letters. Done. End of story. There's nothing else that you need to know. And of course, well, everything shows up in order. You keep those two in mind, you'll be fine for anything that I would ever ask. Okay, just the big letters come first. Okay. The reason why the big letters come first, so for those who take a course where you learn about something called the ASCII table, take a look at the ASCII tables and where they appear. The uppercase letters come first and the lowercase letters come afterwards. Now, we've got some really, really bizarre and unexpected things that can happen, so I better cover them. And okay, 5 minutes and then we'll be finished. This will be the last thing. I'll even leave out the final slides because it's just about ands and ors and nots. Okay, I have to include this one because it might explain something. Okay, remember, I can type anything in here that I want. I can type the number 56. And I can type the number 98. And I'm going to ask, okay, we'll even try running this program, is X less than Y? And the answer is yes, because if 56 and 98 appeared in a dictionary, the 56 would happen first. So let me clear it, just no confusion. Yeah, there we go. So that is true. Okay, yeah, that makes a lot of sense. Okay, but this one right here, does 56 come before 9? Yeah, there's the problem. Okay, so when you have values inside quotation marks, it's looking at it from a character by character point of view. And this is exactly what it does. It compares the 5 and the 9, and it says, okay, is X, which is 5, less than 9? And the answer is yes. And as a result, yeah, you start to get some really bizarre things. Okay, if you ever notice instructors in D2L doing things like this, Lab 01, Lab 02, Lab 03, Lab 04, Lab 09, Lab 10, Lab 11. If you ever see that, do you know what they're doing? They're putting numbers in front so that when things get sorted alphabetically, it shows up in the right order. Because if you don't do this and you ask to sort it, you get these really bizarre things where you'll see something like, so if I put this one, this one, and this one, what you end up getting is something that looks like this, Lab 11, and then these ones down here. That's honestly what it looks like. Okay, here, I can even prove it to you, because this type of thing happens and it really drives me absolutely crazy. Just give me 1 second. We might as well make fun of somebody and then you can go home. That's at least our job here, is make fun of at least one person on campus. This is always the one we like to make fun of. Let me just get logged in first. Okay, here you go. So who are we going to make fun of today? Oh, everybody likes to make fun of this one, right? Okay, so you know the system. Okay, so I'm going to show you a class list. And it's going to take forever. Why? Well, because it's slow. Okay, we can make fun of them. Okay, give me a second. The first page is not particularly exciting. It's also really slow. Sorry, I should have started this beforehand. I just want to do one quick demonstration, I promise. Like, it's not going to take 20 minutes to load, is it? Okay, it will take 20 minutes to load. Okay, the final page, by the way, has ands and ors and nots. I assume you guys remember that, but here you go, search. All right, here's something I do quite often is like, okay, who's teaching the various sections? I need a list because I need to have like a roster about who's going here. So here's what I'm gonna do is I'm gonna say, okay, give me all the INFS 1201 sections so I can figure out who's teaching it. Here we go, and take a look at this. At the very top is section number 1, that's easy. And what comes next? Section 10. Then section 11, then 12, then 13, then 14, then 16, then 17, then 18, then 19, then 2. Right, and then 20, and 21, and 22, and 23, then 3, then 4. You can see why sometimes having the extra 0 at the beginning could solve this problem. Unfortunately, they don't do it here. So if I'm going through and I say, okay, I've got to get a list of all the instructors for all the sections, guess what I'm doing? Here, 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 here. This is a problem with lexicographical ordering when you're storing strings instead of numbers, and I'm pretty sure that's what they're doing. They're sorting by strings rather than numbers. That's why we get 2, 21, 22, and then eventually 3. Okay, so there you go, a real life thing. All right, so, well, as promised, by 10 after I would be done, so yeah, I'm done for the day. Okay, come back next week, if you dare, and we'll actually begin some new stuff. I think I do a little bit of stuff about reviews of loops on the first class. The second one's about functions. That is probably going to be some new things.